Hello everyone, we are project group number 5. We have taken up Amazon Fine Food Product Review Analysis as our project. And before we get into the introduction, let's see what the team looks like. My name is Suryanarayan Sudarshanam. We have Deepen Panchal with us as well as Abdullah Kheruwala. Now let's get into it. So, apart from the willingness to do good for the community along with getting good grades, our primary motivation for the project is as follows. As data has grown exponentially in the past decade, so has its potential. Getting valuable insight from a data set would help change the face of an organization. Our sole aim is to tap this potential and figure out some key insights about the dataset. This would obviously help us as data analysts in the future. In the previous milestone, we figured out what data set we would be using, but we were figuring out how to carry out operations on the data set. But thanks to this programming assignment that we did, we got a direction to follow. As you can see, we have used the Amazon Fine Foods dataset from Kaggle. It contains about 500,000 reviews from October 1999 to October 2012 for about 74,000 products. We will leave a link to the dataset in the description. Now, as everyone is aware about what dataset we used, let's get an overview of what's going to be explained ahead in this presentation. Based on the dataset, here is what we thought would hold importance: determining top 100 useful products, determining which users reviewed which product, determining the helpfulness ratio of all the products in the store. To carry these out, we had to tweak the dataset according to our needs and then find key insights of results, if you will. All this will be discussed in detail later. Now let's get into the design with Deepen.
Hello everyone, my name is Dipen Panchal and I'm going to talk about the design and implementation of our project. So as you are aware, our dataset is Amazon Fine Foods. So these are some of the attributes of our dataset. We had more than 500,000 reviews by more than 200,000 users. So this is a glimpse of the dataset that we used for this project. There are columns for product ID, user ID, the profile name, and something very important is the helpfulness numerator and the denominator that we talk about in a while. Also, it also has a summary of all the reviews and the actual text. Now, the data was very inconsistent and it needed some cleaning so that we could use it for our project. So that's what I'm going to talk about. So, like I mentioned, we had to clean the data set. So we did some data pre-processing using RStudio. Now we just fetched the rows that we needed for each of the implementation we had. For instance, for Amazon top 100 useful products, we just needed the product IDs and their score. So we extracted those using RStudio. And for helpfulness of the products, we needed the product ID, the helpfulness numerator, and the denominator that I showed a while back to calculate the helpfulness ratio. So what you see in front of you right now is the code that we have written for finding Amazon top 100 products, the MapReduce. We have used MapReduce in this. This is not the entire code, but just a glimpse of it. So we have done three analysis. One is finding the top 100 products that in the data set. Now, to find those top 100 products, we use two mappers and two reducers, and we what we did is we used chaining for this. So basically the output of the first map reduce goes to becomes the input of the second one. Now, like I mentioned, we have two map reduces. So the first map reduce finds the averages, of the score for each product. So basically, there will be a lot of score for one product, and the first map reduce calculates the average of that score for each and every product, and it sorts it. Uh, it just displays it, and in the second map reduce, now that we have the averages of each product, which means that there is one score for each product. The second map reduce will give us will sort the top 100 products and give us what those product IDs are. So the product ID is the key and the score is the value as the output of the second map reduce. So on this slide, you see the group comparator and the reduce function that I was talking about earlier. This was for the Amazon top 100 products. Now for the Amazon inverted index application, we just have one mapper and one reducer. Basically, what this does is it calculates the inverted indexing. Now this is very helpful as the output can show what products are reviewed by which users. So if you want to go ahead and evaluate some products and know which users are genuine, and which users have actually brought the product, so that because they've rated it, so they should actually buy the product, right? So this index can help us understand which users are genuine and which users have actually brought the products. So the third one is the helpfulness ratio that we've tried to calculate. Now imagine someone shopping on Amazon. What is if you find a product that you want to buy? I think most of the users would go down and read the reviews by other users. So it is very important for every user to find what other people are saying about a particular product. So that is what we have tried to calculate. So our data set gives us helpfulness numerator and denominator for every product. So we've used one map reduced to find the helpfulness ratio. What we've done is we've averaged the values of numerator and denominator, and we've found out the helpfulness ratio, and we've multiplied it by 100, and we have displayed those helpfulness ratio for every product. Now this helpfulness ratio will tell the users who are planning to buy a particular product that these are the other people who have reviewed this product, and this is how helpful this review is. And I think it helps a lot because imagine you going through a lot of reviews and you don't know which one's genuine. So I think the helpfulness ratio helps a lot to identify that. Again, this is just the reducer function of the helpfulness ratio that I was talking about. Now, after talking about the code and the design of our project, let's move on to the implementation and see how what technologies we have used to implement this. We've used MapReduce to sort the data and determine all these products. Obviously, because like I showed in the data set, we got a list of all the product IDs and their reviews. So we did not use Pig or Hive because the problem wasn't that complex. So we decided to go out with MapReduce because that would give us the sorted list that we needed. Also, like I mentioned earlier, we had to clean the data set, so we did some pre-processing and we fetched the data we needed using RStudio. And obviously, the code is written in Java. And we used Amazon Web Services. We used the Ubuntu AMI to test our project. So that is the technology stack that we have used. So the next two slides are just data visualization of the data that we had in our data set. Basically, the score and the helpfulness numerator denominator versus the product ID. So this was just a pre-exercise that we were trying to do to understand, how the data stands against the product ID. So we plotted a matrix just to see, the behavior of the data. That is what you see on this slide. Similarly, on this slide, we see the graph which shows the frequency of score, helpfulness numerator, and the denominator. The reason why we did this is to understand, what is the expected output that we should be getting, because it is very essential to, understand and study the data before, so that we can understand so that we can understand whatever output we get is something that we are expecting or not. It shouldn't be something it shouldn't be something for something unexpected. This was very helpful for testing purposes, so we actually went ahead and use Tableau to visualize the data.
Thank you, Deepen. Now let's see what our results look like with Abdullah.
Hi everyone, this slide shows evaluation results for Amazon Top 100 Products analysis of Amazon Fine Food Review dataset. This filtering pattern outputs the top products and the output file shows the product IDs and their corresponding rates. We are using two mappers and two reducers. The first mapper reducer outputs the product IDs and their average score. Second mapper reducer outputs product ID of top products and their corresponding scores, that is ratings. The first column is the product ID and the second is their corresponding ratings. Second analysis is for the Amazon helpfulness ratio from Amazon Fine Food Review dataset. In this analysis, we have taken ratio of helpfulness numerator and helpfulness denominator for each value and averaged the value. The ratio is then multiplied with 100 and output only shows up to 2 decimal places for the float values. Output shows product ID and how much those product reviews were useful to other users in percentage. We are using one mapper and one reducer for this analysis. The first column in the output shows the helpfulness percentage and the second one shows their respective product IDs. Results of our third analysis. In this analysis, inverted indexing is used. It is very helpful as the output shows what products are reviewed by which users. The key value will have multiple values. Output shows which users reviewed a particular product for all products using their product IDs. One mapper and one reducer used for this analysis. Output shows product ID and user IDs. This is the analysis of scalability as a function of the different cluster size and different data size. Actual data size is 300 megabytes. So we did analysis on the data set of size 300 megabytes, 250 megabytes and 200 megabytes for cluster size of 2, 3, 4 and 5. That is the number of virtual machines in master-slave node architecture. Following is the analysis of a scalability for Amazon Top 100 Products analysis. Following is the analysis of scalability for Amazon helpfulness ratio analysis. Following is the analysis of a scalability for Amazon inverted index analysis. Now evaluation for a node failure. Steady performance degradation in the presence of node failures. So after rebooting for a new cluster size, one virtual machine data node is killed and the same virtual machine is killed again twice without rebooting to record execution time. The virtual machine is killed after a random delay between 0 and the execution time of the program on the cluster without failures. Also, virtual machine can be killed before or after start of the job. This slide shows the evaluation for a node failure in Amazon helpfulness ratio analysis. This is the evaluation for a node failure in Amazon inverted index analysis. Conclusion. Analysis on the Amazon Fine Food Review dataset can help Amazon products with its sales, scope of improvement, and honest user reviews for other users buying similar products. Also, based on analysis, we conclude that positive reviews are very common. Positive reviews are shorter, longer reviews are more helpful. Also, despite being more common and shorter, positive reviews are found more helpful. Frequent reviewers are more discerning in their ratings, write longer reviews, and write more helpful reviews. Further analysis. Analyze by category of product. That is, the dataset used contains product IDs but not a categorization of the products. Getting more information on the categories of products or using the review text to gain product information and then doing analysis across product category would be interesting. Second is developing a model for predicting a review's helpfulness based on user rating and the text of the review. Third is investigate the relationship between the products and the user and the reviewers. For example, do certain groups of reviewers review similar groups of products? At last, using Apache Mahout for user-based and item-based recommendation. Thank you.
Thank you, Abdullah. Now that we have concluded our presentation, we would like to take questions in the forum or in the comments down below. Thank you.